Welcome back to your review for the Semester 2 final. We're on to problem 6, which came from lesson 6.8, more exponential graphing. We're given two different equations, one that I'm going to do in blue, f of x equals 3 times 4 to the x, and the other that I'm going to do in red, g of x equals 3 times 2 to the x. They're asking us to compare these two functions and determine which of the following statements are correct. Now I'm going to quickly glance at the statements, see what information I need from these equations, find the information, then go back to the answers. For example, it says somewhere we're going to need an x-intercept. We are also going to need some y-intercepts. And then we also have to discuss the rates. All right, so let's break these down. If you look at an equation, y equals a times b to the x power, because the y-intercept is always found by replacing x with 0, this guy will go to the 0th power, which means this guy turns into, what is anything to the 0th power? Well, that's 1. So the only thing that's going to be left is the a value here. This means then that our y-intercepts, and I'm going to compare them just over here, our y-intercept is just the a value of each of these equations. So 0, 3. And this guy over here is also 0, 3. So they have the same y-intercept. Let's go ahead and look at the x-intercepts. To find an x-intercept, we need to go through and replace the y with 0. So I'll just show this on the blue one down here. If I do 0 equals 3 times 4 to the x, we're trying to isolate x. I can at least divide by 3. 0 equals 4 to the x power. But then we don't know how to solve this equation, right? The question is, what power will turn 4 into 0? And we covered this more in depth on problem 5, but we tried a positive number, 0, and a negative number here, and none of those resulted in 0. Remember, an exponent of 0 gives us an answer of 1. And in fact, this is an example of an equation that has no solution. This graph, or actually any exponential we do this year, will not have x-intercepts. So when they ask you to compare the x-intercepts, there are no x-intercepts for either equation. All right. Last but not least, they asked about the rate. The rate is what we multiply by every time, and that is our b value. So our rate here is actually the number that x is attached to. So I'm going to go through and say, okay, well, if I want to compare the rates of each equation, the rate of the first one is multiplying by 4, and the rate of the second one is multiplying by 2. In fact, if you really wanted, you could just compare the two graphs pretty quickly from here, I think. I'll even put them on the same xy axis. Okay, it looks like they have the same y-intercept, 0, 3, so I'll do 1 in blue, and then kind of right on top of that I'll do 1 in red. It looks like, though, the rate of the blue function goes up by 4 every time, so that goes up really fast over here. So my blue function looks like this, versus my red function doesn't go up as quickly. So my red function is only doubling every time, and so we're going to have something that looks like this guy. Okay, and so we can see kind of those two rates right away. Now, actually answering the questions, is the x-intercept of f of x greater than the x-intercept of g? Well, they have no x-intercept, so we can't really compare them. Is the y-intercept of f greater than the y of g? No, they have the same. Do the functions increase at the same rate? No, f of x goes up times 4 every time, g of x times 2. Last but not least, do the functions have the same y-intercept? Why, yes, they do. Got to be D. Thanks again for tuning in.